Good morning, students. Today's topic is polar form of a complex number. Under that, modulus and amplitude of a complex number. Every complex number can be expressed in the form of r cos theta plus I sin theta. Every complex number can be expressed in the form of r cos theta. R cos theta plus I sin theta, where r is called the modulus of the complex number, where r is called the modulus of the complex number, and theta is called the amplitude of the complex number, where r is the modulus of the complex number and theta is called the amplitude of the complex number. Okay. Let z is equals to x plus iy. Let z is equals to x plus iy. Let z is equals to x plus iy be any complex number. This can be expressed in the form of p of xy. This can be expressed be any point at p of xy. Let us illustrate with an example. That diagram we write. Okay. Let us write the figure diagram. So this one is x-axis, this one is x dash, y-axis, y dash. So this one is origin O, P, M, P of xy, P of xy. This OP is the R, OP is R, which is nothing but modulus of Z. R is the modulus of Z. This OM is X and PM is Y. Okay. If you take the right hand triangle, this one is called the theta. Triangle OXP, XOP. So in this OM is equals to X, PM is equals to Y, R is equals to modulus of Z, which is equals to what is modulus of Z, which is equals to square root of x square plus y square. So here PM is perpendicular to the x-axis. PM is perpendicular to the x-axis. OM is equals to x, PM is equals to y, and OP is equals to R, which is the modulus of Z. Z is equals to x plus iy. If I consider the triangle OMP, what is sin theta? Sin theta. Sin theta is equals to y divided by r. Sin theta is equals to y divided by r. What is y? Y-axis, that is equals to ordinate. Ordinate divided by radius. Sin theta is the ordinate. And this one is the radius. Okay? Ordinate divided by radius. Similarly, what is cos theta? What is cos theta? Cos theta is equals to, in the same triangle, cos theta is equals to x divided by r. X divided by r. What is x here? So x is the abscissa. X is the abscissa. X-axis, abscissa. This one is the radius. Okay. Sin theta, if I consider the triangle OMP, right hand triangle OMP. So this sin theta is equals to y divided by r. Cos theta is equals to x divided by r. So after transposing, what will we get? So y is equals to r sin theta. Y is equals to r sin theta. This equation becomes, how does it become? So x is equals to r cos theta. X is equals to r cos theta. Y is equals to r sin theta. If we have to substitute this, x is equals to r cos theta and y is equals to, what is y value? Y is equals to r sin theta. In the equation, z is equals to x plus iy. So every complex number can be expressed in the form of r of cos theta, r cos theta plus I sin theta, where r is called the modulus of the complex number and theta is called the amplitude of argument of the complex number. Let p of xy, let z is equals to x plus iy, so be any complex number. This can be expressed at any point p of xy. This can be expressed at any point p of xy. By using this diagram, this Pm is perpendicular to the x-axis. Pm is perpendicular to the x-axis. The angle, this OX, we have to consider this triangle. This, what is the OPX, the triangle OPX. Okay. So Pm is perpendicular to OX, this x-axis. So OM is equal to x. OM is equals to x, PM is equals to what? PM is equals to y, and OP is equals to r, the radius r. OB is equals to the radius r. So if we take the triangle OMP, so sin theta, what will be sin theta? Sin theta is equals to y divided by r. After cross multiplication, you will get y is equals to r sin theta. So cos theta is equals to x divided by r, abscissa divided by radius. So x is equals to r cos theta. We have to substitute this equation in complex number. So what is the complex number? Complex number z is equals to x plus iy. So we have to substitute here. Z is equals to x plus iy. What is x value? X is equals to r cos theta. So I we have to write as it is. Y value is what? R sin theta. R cos theta, R sin theta. If you take R as common, what will be the remaining terms? Cos theta plus I sin theta. Cos theta plus I sin theta, where r is the radius of the complex number. This one is the radius or modulus of the complex number. R is the modulus of the complex number. Modulus of the complex number. Modulus of the complex number. What is the modulus formula? We have discussed in the previous class. Modulus is equals to vertical bar z, which is equals to square root of x square plus y square, where r is the modulus of the complex number and theta is called amplitude of the complex number. So we can call it as argument of the complex number, or amplitude or argument of the complex number. Theta is called amplitude, r is called the modulus of the complex number. So this one is called the polar form of a complex number. What is this one? Polar form of a complex number. Polar form of a complex number, or trigonometrical form of a complex number. Another name for polar form of a complex number is trigonometrical form of a complex number. Another name is also there, that is standard form of a complex number. What is the standard form of a complex number? R is equals to, here it is z, z. Z can be expressed x plus iy. Z is equals to r of cos theta plus I sin theta. So standard form or polar form or trigonometrical form of a complex number is z is equals to r of cos theta plus I sin theta. You understood this one? Where r is the modulus of the complex number and theta is the amplitude of the complex number. R is called the modulus. So what is the modulus value? R is equals to modulus of z, which is equals to square root of x square plus y square, and theta. In theta we are going to write, it depends upon the quadrants in which it lies. So it must be in first quadrant we have to go for theta is equals to tan inverse of pi by x. If it is in second quadrant we have to go for theta, that is amplitude is equals to pi minus tan inverse of y divided by modulus of x, like that. It depends upon the quadrant in which it lies the complex number. So according to that we have to write the formula. Okay. So this one is the polar form of a complex number. So any complex number can be expressed in the form of r of cos theta, r of cos theta plus I sin theta, where r is called the radius or modulus of the complex number and theta is called the amplitude of the complex number. So if we take the triangle, rectangle triangle, we will get sin theta as y divided by r, cos theta as x divided by r. If we substitute those two values in this equation, z is equals to x plus iy, you will get z is equals to r of cos theta plus I sin theta. So this one is called the polar form or a standard form or trigonometrical form of a complex number. Okay. You understood this one? It is coming for 2 marks also, 3 marks also. This based on this, the problems are very important. If you ask what is the polar form of a complex number, you have to tell the polar form of a complex number is z is equals to r of cos theta plus I sin theta. Okay. So depends upon the quadrants, okay, how to find the amplitude. How to find the amplitude. Finding the amplitude. Amplitude. Okay. So amplitude in which quadrant lies. You know the quadrant now? How many quadrants are there? How many quadrants? 4 quadrants. First quadrant, second quadrant, third quadrant, fourth quadrant. So where r is called the radius, r is called the modulus. So what is modulus of z? It is nothing but r only. Okay, don't get confused. X square plus y square. So theta is equals to tan inverse of y divided by x. This one is the amplitude. Amplitude of complex numbers. You should know that r is equals to square root of x square plus y square. Theta is equals to tan inverse of y divided by x, where theta is the amplitude of a complex number. So in first quadrant, plus, plus. What are the signs of first quadrant? It is plus, plus. Why it is plus, plus? Because this one is x axis, no? This one is y axis, y dash axis, x dash axis. You know the number line, that is a set of integers. So positive 0, in between 0, middle 0, towards right side of 0, the positive values. This is equals to 1, 2, 3, up to infinity. Here also positive values no, we get in y-axis 1, 2, 3. And here -1, -2, -3 up to infinity, -1. That is x-axis value. Okay. So it will be like this. That is why x-axis, y-axis both are positive now here. X-axis is positive, y-axis is also positive. For this, theta is tan inverse of y by x. We have to remember this formula according to the quadrant in which it lies, in which the complex number lies. Depends upon that, we have to write the formula. Then only you will get the absolute amplitude of a complex number. Otherwise, you will get the wrong answers. So, what is in second quadrant? First quadrant. This one is second quadrant. So first we have to write x-axis now. If it is in 180 degree, that is theta is equals to pi minus tan inverse of y divided by modulus of x. This is the formula. Okay. So theta is equals to pi minus tan inverse of y divided by modulus of x. Okay. This because this is a negative value, no. That is why I am putting modulus of x. So in first quadrant, if the problem is on first quadrant, you have to substitute theta is equals to tan inverse of y divided by x. If the problem is, if the complex number is on second quadrant, it lies on second quadrant, we have to substitute theta is equals to pi minus tan inverse of y divided by x. If it is in third quadrant, minus of pi minus tan inverse of y divided by x. We have to put the modulus sign for both y-axis, y divided by x, because both are negative here. So for third quadrant, what is the sign? X-axis, y-axis you have to write. Both are minus, no, minus, minus, plus, plus. What is the sign? Minus, plus, minus, plus. Third quadrant, minus, minus. What is fourth quadrant? Fourth quadrant. So x-axis is plus, y-axis is minus. So theta is equals to minus tan inverse of y divided by x, modulus of y divided by x. These are the important four formulas. These are the important four formulas. Theta is equals to tan inverse of y by x, pi minus tan inverse of y divided by modulus of x, minus of pi minus tan inverse of y divided by x. Theta is equals to minus tan inverse of y divided by x. Okay, this one is the quadrant. So you are finding the amplitude of a complex number. You have to, you should know all the three amplitude formula. If it is in first, if the complex number lies in first quadrant, you have to write r will be same. You have to write the x value and y value. R is equals to square root of x square plus y square, and with theta, if it is first quadrant, you have to write theta is equals to tan inverse of y divided by x, where theta is equals to pi minus tan inverse of y divided by modulus of x. You have to read modulus of x. If it is in third quadrant, if the complex number is in third quadrant, we have to write theta is equals to minus of pi minus tan inverse of modulus of y divided by x. If it is in fourth quadrant, theta is equals to minus tan inverse of modulus of y divided by x. You have to write this neatly. You should know this rule. Then only you can do the problem. You can solve the problem. Otherwise, you won't get answers in to get right answers. Okay. So to solve the problems, to find the polar and amplitude of a complex number, we need to know the trigonometric functions of standard angles. We know the tables, the tan values we should know. Then only we can solve finding theta. After this, we have to know the values of trigonometric functions of standard angles. Okay. Shall I rub this one? Students should write this. Okay, this is also, and next I am going to do the tables. So many 0 to 360 degrees there. Standard angles. Okay. Next, trigonometric ratios of standard angles. Trigonometric ratios of standard angles. Trigonometric ratios of standard angles. Here is theta, sin theta, cos theta, tan theta. And sin theta will use this in the normal form only. Sin theta, cos theta, tan theta. In school days we have learned, right? And cosecant theta, secant theta, tan, cot theta. And those are the reciprocal of the sin theta, cos theta, tan theta. Here 0 degree, 30 degree. For 30 degree, the sine is in pi by 6. This one is in radians. It is in degrees. Okay, next after 30 degree, 45 degree. 45 is pi by 4. 60 degrees, pi by 3. And next 90 degree, pi by 2. Okay. So sin 0 is 0. Sin 30 is 1 by 2. Sin 45 is 1 by root 2. Sin 60 degree is root 3 divided by 2. So sin 90 degree is equals to 1. We should know these values first. 0, 1 by 2, 1 by root 2, root 3 by 2, 1. So sin 0 is 0. Sin 30 degree or sin pi by 6, which is equals to 1 by 2. Sin pi by 4 or 45 degree is equals to 1 divided by root 2. Sin 60 degree or pi by 3 is equals to root 3 by 2. And sin 90 degree is equals to 1. So writing cos theta values reverse we have to write. 90 degree is there, no? 1. What is 60 degree? So it will be going to be reverse, okay? So root 3 by 2. And this 1 by root 2. 1 by 2. And 0. Okay? Very easy. You have to remember only this much. 0 degree, sin 0 degree, sin 30 degree is 1 by 2. Sin 45 degree is 1 by 2, sin 60 degree is 1 by root 3 by 2, and sin 90 degree is equals to 1. So writing cos theta, we have to reverse the values, then we will get. So in this one, we know that tan theta is equals to sin theta by cos theta. So sin theta 0 divided by 1 is equals to 0. So 1 by 2, 1 by 2, root 3 by 2, 2 will cancel, no, like that. So tan theta 0, these two will cancel, 1 by root 3, everything will get cancelled, 1 by 1, 2 will get cancelled. Root 3, 1 by 0 is infinity. Okay? So 0, 1 by root 3, 1, root 3, infinity. So if you go for sin theta is 1 by cosecant theta, cos theta is 1 by secant theta, tan theta is 1 by cot theta. For this chapter, this is much enough, okay? So you have to sin tan 0 is 0, tan 30 degree or pi by 6, it is equals to 1 by root 3, tan 45 degree is 1, tan 60 degree or pi by 3 is equals to root 3, tan 90 degree is equals to infinity. This much you should remember, okay? We'll study in detail. There is so it will take almost more than 20 periods, 20 hours for doing trigonometric functions. In the next session we'll start, okay? So students they found difficult, that is why we started this chapter. It is easier only. It is also easy. Trigonometric function is also easy, but you need to concentrate. You have to adjust for this class. Then only you can. Okay? You understood this? 0, 0, 30 degree, 45 degree, 60 degree, 90 degree. So 0, 1 by 2, 1 by root 2, root 3 by 2, 1. So for writing cos theta values, reverse order 1, root 3 by 2, 1 by root 2, 1 by 2, 0. So dividing 0 by 1, 1 by 2, root 3 by 2, 2 get cancelled, 1 by root 3. These two get cancels, 1, 2 get cancels, root 3, 1 by 0 is infinity. Are not defined also, not defined, does not exist. We will do it in trigonometric functions, okay? So to find this polar form of a complex number, we should know all these things, okay? Otherwise, it's not easy. Okay? You should know. It is easy only. You practice it. Okay? You write. You remember these tables. You glance the tables. While solving the problems, you write sidewise these values, then it will be easy, okay? 0 degree, 5 by 6 is 30 degree, 5 by 4 is 45 degree, 5 by 3 is 60 degree, next 90 degree, 5 by 2, 90 degree. Only tan theta values remember, okay? That one is 0 now. What is tan by 6? 1 by root 3, 1 root 3, infinity. For solving the problems, this is important. You can remember this much for this writing polar form of a complex number, okay? Next. Write the polar form of a complex number. Very important. It is common for 2 marks, 3 marks. Okay, it is very important. We have to practice. We are going to write all the 3 marks to 2 marks questions. Write the polar form of a complex number. Question is write the polar form of a complex number. Z is equals to 1 plus I. Z is equals to 1 plus I. This is the problem, okay? It is important also. We have to find the polar form of a complex number or write the polar form of a complex number. So Z is equals to 1 plus I, 1 plus I. First we should know what is the polar form of a complex number. Z is equals to R of cos theta plus I sin theta is called the polar form of a complex number, where r is equals to square root of x square plus y square, which is called as the modulus of a complex number, where theta is called the amplitude of a complex number. Theta is called the amplitude of a complex number. So, it is in which quadrant it lies, this complex number. First, we have to check that one only. This complex number z is equals to 1 plus I, in which quadrant it lies? In which quadrant? See, 1 pakka yenide, plus I pakka yenide, plus ide tane, plus yav quadrant alli barutte? Plus first quadrant alli barutte. It lies in first quadrant. So, ಇಷ್ಟು ಗೊತ್ತಾಗಬೇಕಂದ್ರೆ it lies in first quadrant. ಯಾವ quadrant ಅಲ್ಲಿ ಇದೆ ಅಂತ. ಆಮೇಲೆ we have to find out the r value. R value find out ಮಾಡಬೇಕಂದ್ರೆ what is the formula? X square plus y square. R radius ಅಥವಾ modulus of the formula. So x ಅಂದ್ರೆ ಇಲ್ಲಿ ಇದು ಪಕ್ಕ this is the first part. Now this one is the value of x. 1. X is equals to 1. Y ಅಂದ್ರೆ I ಪಕ್ಕ ಏನಿದೆ 1 ಇದೆ ತಾನೆ. So y is equals to 1. X is equals to 1. Y is equals to 1. So if you compare this equation, x plus iy, so this x is 1 now and y is 1 now. So I pakka ಏನಂದ್ರೆ 1. If there is nothing is there, 1 is there. X plus iy. So x is equals to 1, y is equals to 1. So how to find? R is equals to, what is x value? 1 square. Y value 1 square. 1 square is 1. 1 square is 1. R is equals to square root of 2. We got the R value. R value is square root of 2. Next, what we have to find out? We have to find out the theta value. Theta is the amplitude. So theta is equals to tan inverse of y divided by x. Why only this formula? Because both the signs are positive, it lies in the first quadrant. So plus. So we have to write this one because it lies in the first quadrant. So tan inverse of, what is y value? Y is 1 now. X value is also 1. So tan inverse of 1 by 1 is 1. So tan inverse of, what is 1 here? 1 is tan pi by 4, no? So 1 can be written as tan pi by 4. It is there, no? Pi by 4. Tan pi by 4 is equals to 1. So which is equals to pi by 4. Theta is equals to pi by 4. We got r is equals to root 2 and theta is equals to pi by 4. We have to substitute this r value and the theta value where we have to substitute in polar form. What is the polar form? R. Z is equals to r of cos theta plus I sin theta. So z is this complex number. What is this? 1 plus iy. You can write also, otherwise you can write 1 plus z only, 1 plus I. What is r value? R value we have got as root 2. Cos. Theta is what? Theta amplitude pi by 4 plus I sin pi by 4. This one is the polar form of a complex number. Polar form of complex number Z. You understood this problem? This is a very easy also. First we have to write out R value, square root of x square plus y square. So which is equals to root 2 because x value is 1, y value is also 1 and amplitude, to find the amplitude, theta is equals to tan inverse of y by x which is equals to y is 1, x is 1. So 1 by 1 is 1. So 1 is nothing but tan pi by 4. You can write somewhere here 1 is equals to tan pi by 4. You can see that trigonometric functions of standard angles. 1 is equals to tan pi by 4. So pi by 4 is 1. So nullify, you can nullify this one. Otherwise, so theta is equals to pi by 4. So which is equals to the complex number. Okay? Next, root 3 plus I. Write the polar form of the complex number. Z is equals to root 3 plus I. Root 3 plus I. Okay? So first we have to, what we have to check? We have to check whether in which quadrant this complex number lies in which quadrant. In which quadrant it lies? First quadrant. First quadrant means plus plus now. What is R value? Square root of x square plus y square. Square root of x square is what here? X is root 3. Okay, don't get confused. Root 3 whole square. Y is I papa everyday 1 tane. Y is 1 square. See, this root cancels. Okay, in school days you have not cancel this. So we get 3 plus 1. So it is equals to square root of 4, which is equals to 2. What is R value we have got? R is equals to 2 because square root of 4 is equals to 2. Next, what we have to find out? We have to find out the amplitude or argument of the complex number. What is the amplitude of the complex number? It depends upon in which quadrant it lies. If it is in first quadrant, we have to write amplitude as theta is equals to tan inverse of y by x. So theta is equals to tan inverse of y divided by x. So tan inverse of, what is y value? This one now, you can write here x is equals to root 3, y is equals to 1. So 1 divided by root 3. So for this you can check the table. So what is there? You have to write it in radians only. Okay? So tan inverse. So tan, what is there now? For 1 by root 3, pi by 6 is there now. Pi by 6. Therefore theta is equals to pi by 6. What is the polar form of the complex number? Z is equals to r cos theta plus I sin theta. What is R Z? What is Z? Root 3 plus I. Root 3 plus I. Root 3 plus I. R value we have got as 2. 2 of cos theta. This one is theta pi by 6 plus I sin pi by 6. So till here we have to do. This is easy also, important also. You can do it in these problems in the examinations very easily. Okay? I will send the notes also, students, okay? Don't worry about it. I will send the notes. If you want, you can until there. If you want, you can write this. You can go to the classes, refer this, okay? Try out the different examples also. I root 3 minus 1. We have to write it in the order first. So in x plus I form. How it will be? What is x value here? X is minus 1 plus I root 3. We have to write like this. Okay? So what we have to find out? We will write here x is equals to minus 1. Y is equals to root 3. X is equals to minus 1. Y is equals to root 3. Okay? We have to write like this. First, we have to check it also. In which quadrant it lies? Minus plus. In which quadrant? Plus is first quadrant. Minus plus because x dash and y. So minus plus. Second quadrant, no? Correct. Second quadrant. We have to write second quadrant. So what is R value? R value is what? R is equals to square root of x square plus y square. So which is equals to square root of x is what? Minus 1 whole square plus y is root 3 whole square, which is equals to minus 1 whole square is what? Which is equals to 1 only, no? 1 plus this root 3. 2 square and this 2 will get cancelled. So 4, which is square root of 4 is 2. So therefore R is equals to 2. R is equals to 2. What we have to do now? Next we have to find out the amplitude. R value is 2. So theta, what is the formula? Theta is equals to pi minus tan inverse of y divided by x. So we have done all this according to the quadrants. First quadrant we have to write theta is equals to tan inverse of pi by x. Second quadrant theta is equals to pi minus tan inverse of y by x, like that. So pi we keep as it is minus tan inverse of what is y value? Y is root 3. Okay? X is minus 1. Okay? Pi minus tan inverse of root 3. So it is modulus, it will become plus. Okay? It will become plus. So pi minus tan inverse of root 3. Pi minus tan inverse of what is root 3? Root 3 is pi by 3. This pi by. So tan pi by 3. Tan pi by 3. So it is equals to pi minus pi by 3. You know the simplification, cross multiplication, 3 into pi, which is equals to 3 pi. Minus 1 into pi is pi. Divided by 1 into 3 is 3. The answer is theta is equals to 2 pi by 3. So therefore z is equals to r is to know cos 2 pi by 3 plus I side divided by this one is the polar form of the complex number. Okay. So for this one is for 2 marks, this is an outcome for 2 marks, and we'll solve it for 3 marks also in the next session. We'll solve one of this A plus I form. Express the following in the form of A plus IB. Express the following in the form of A plus IB. This one is important. 1 by 3 plus 3i. 1 by 3 plus 3i whole cube. Okay? We have to write this in the form of A plus IB. So this problem, it is of the form A plus B whole cube. Right now, A plus B whole cube. What is A plus B whole cube? A cube plus B cube plus 3 plus 3AB of A plus B. A cube plus B cube plus 3AB of A plus B. What is A plus B whole cube formula? A cube plus B cube plus 3AB of A plus B. Okay? A cube plus B cube plus 3AB of A plus B. Or we can write like this also. A cube plus B cube 3A square B. 3A square B plus 3 AB square. Like this also we can write 3A square B plus 3 AB square. Okay? So this one is important. So better go for this. If it is this form, no, you may get confusion. Okay? Better go for this. What is this one? 1 by 3 plus 3i whole cube. Here A is what? A is 1 by 3, B is 3i. Okay? What is A cube? 1 by 3 whole cube. Slowly do. B cube is 3i. 3i whole cube. 3i because B is 3i. So whole cube plus 3. A square. A square means 1 by 3 whole square. A square is 1 by 3 whole square into B. B is 3i plus 3. What is A? 1 by 3. B square. B square is 3i whole square. So this is the expansion. 1 by 3 whole cube plus 3i whole cube plus 3 into 1 by 3 whole square into 3i plus 3 into 1 by 3 3i whole square. Okay? So we have to substitute. What is 1 by 3 whole cube? 3 3s 3s are 9, 9 3s are 27. 27 plus 3 cube 27. I cube can be written as I square into I. Okay. Plus 3 into 1 by 3 square, which is equals to 1 by 9 into 3i. So, are you following? So, 1 by 27, 1 cube is nothing but 1 only, 3 cube, like this. 3 into 3 into 3, 3 times, 3 3s are 9, 9 3s are. Okay, 3i cube, 3 cube is 27, I cube can be written as I square into I plus 3 into 1 by 3 whole square is 1 by 9 into 3i plus these two will get cancelled off plus 3 square is 9 no? 9 I square. Okay, 9 I square. So which is equals to 1 by 27, 1 by 27 plus 27 I square is minus 1, I is 1, I keep as it is, 3 1s are, 3 3s are, 3 3 will get cancelled, 27i. So you get only I plus 9 I square value is minus 1. Okay? Which is equals to 1 by 27 plus into minus 27 into 1 into I is 27i plus I plus into minus 9. Okay? Next one. So 1 by 27 minus 27i plus I minus 27i plus I minus 26i minus 26i minus 9. 1 by 27 minus 26i minus 9. So real part we can separate minus 27 minus 9 minus 26i. So cross multiply this one. So how it will be? 243 no? 243. So 243 1 minus do it here. Okay? This becomes so 1 minus 243 divided by 27 minus 26i, which is equals to 242 minus 242 divided by 27 minus 26i. So it is of the form a plus ib. No, this is a plus ib form. So it is a 4 quadrant, no problem. So a plus ib minus 242 divided by 27 minus 26i. Okay? You understood this one? So if you go for a cube plus b cube plus 3ab of a plus b, you will get confusion a little bit. Okay? You better apply this. Both are same only, but here you get somewhat difficulties. So a cube is 1 by 3 whole cube plus b cube is 3i whole cube plus 3 into a is what? We will go this one. A square 1 by 3 whole square into b is 3i plus 3 into a is 1 by 3 into b square is 3i whole square. First we have to substitute according to the formula. We have to substitute this a value and b value. After this 1 by 3 whole cube is 27 now. So 1 cube is 1, 3 cube is 27, 1 by 27 plus 3 cube 27. I cube can be written as I square into I plus 3 into 1 by 9, 3 into 1 by 9 into into 3i. It is there now. Plus 3 it cancels. 3i square is nothing but 9i square. So 9i square. So 1 by 27. So this value I have written here. 1 by 27 plus into minus. Minus 27 into 1 into I is 27i plus I plus into minus. Minus 9 into 1 is 9. So 1 by 27 minus 27i plus I, which is equals to minus 26i minus 9. So real part we take 1 by 27, this 1 by 27 minus 1 by 9. Cross multiply 1 into 1 minus 2 7 into 9, 243 divided by 27. 1 minus 243 divided by 27 minus 26i. So minus 242 because the greater number minus 242 divided by 27 minus 26i. It is in the form of which this a plus ib form. Okay, we'll do it in the next class. You just go for this. Okay, you just go for this. Today's class is very important. Go for this. Okay, you practice similar problems. A plus I, B, A plus B whole cube, A plus B whole square, A minus B whole square. Similar type of problems. You can do it at your home. Okay, thank you.